Namaskar, welcome to Exercise Explained. In this video, I would be doing exercise 7C, Reflection of Light, ICSE 9th Physics. I'd be solving question number 4 and question number 5 in this particular video. So before starting this video, I would tell you to go through the video of sign convention which I have made, the link for which will be there in the description below. Because without understanding sign convention, it's going to be a bit difficult to understand these videos. So let us start with the fourth question. An object is placed at 4 centimeter distance. So this is object distance in front of a concave mirror. Now I would be underlining the term concave. I would tell you in a while why I am doing so. Of radius of curvature. So radius of curvature is given as 24 centimeter. Find the position of image. So we need to find the position of the image. That means we need to find the value of V. And the second part is the image magnified? Now let us understand few things here. The radius of curvature, that is the value of R, is given as 24 centimeters. Now we know the formula F is equal to R divided by 2. So that happens to be 24 divided by 2. That happens to be 12 centimeter. But it is given here that it is a concave mirror. And in case of concave mirror, by sign convention, we know that the focal length should be negative. So the focal length is taken as minus 12 centimeters. Now we have got the focal length. We have the object distance. Now object distance is denoted by U, which is given to be 4 centimeters. So U is given as 4 centimeter, but U is always negative. So I would write it as minus 4 centimeter. So we have got this. Now as you can see here, the focus will be at 12 centimeter distance. Center of curvature will be at 24 centimeter distance. And the object is at 4 centimeter. That means the object is between pole and focus. Now, if you are aware of the ray diagrams very well, when the object is placed between pole and the focus, the image is formed behind the mirror and it is magnified or enlarged. So for the second part of the question, is the image magnified? We can write the answer as yes, the image is magnified. Now we would be finding the value of position of image. That means we need to find the value of V. So we know the mirror formula. So the mirror formula is 1 by F is equal to 1 by V plus 1 by U. So 1 by U goes to the other side. I get 1 divided by V is equal to 1 by F minus 1 by U. I would be substituting the values. 1 by F will happen to be 1 divided by minus 12 minus of 1 divided by U will be 1 divided by minus 4. So now we can write it as 1 by minus 12 can be written as minus 1 by 12. I have explained this in the previous video how this happens, how the minus sign comes up to the numerator. So if you have not watched the previous video, I would tell you to watch that. And minus of minus 1 by 4. So we have got this. That happens to be minus 1 by 12. Minus into minus is plus 1 by 4. So we get minus 1 by 12 plus 1 by 4. Now after this, I would write here 1 by V is equal to the LCM of 12 and 4 will be 12 only. So I will write the LCM as 12. So I write the LCM as 12, and 1 into 12 is 12 into 1 is 12. So here I'll be multiplying by 1. So that happens to be minus 1. And 4 into 3 is 12. So plus 3. So we get it as minus 1 plus 3 is plus 2 divided by 12, which is nothing but 2 by 12 is nothing but 1 by 6. So we have got 1 by V is equal to 1 by 6. So V will be equal to plus 6 centimeter. So since we have got V as plus 6, we can write that it is 6 centimeter in it is 6 centimeter behind the mirror. So the position of the image is 6 centimeter behind the mirror, and we have already told it is magnified. So I have written, is the image magnified? Yes. So we have understood this. Getting to the next problem, that is question number 5. Now question number 5 is a really tricky problem. I would be solving it in two separate ways. So let us start with the first way. So here the question says, at what distance from a concave mirror, so it is a concave mirror, do remember that, of focal length 25 centimeter. So focal length is given as 25 centimeter. Should an object be placed so that size of the image is equal? So we have the size of the image is equal to the size of the object. So here what is given is the size of the image is given by the letter I, and size of the object is given by the letter O. So we know the formula for magnification. So M is equal to I divided by O. So but there is a slight trick here. The trick is I will be negative. So the reason I is negative is whenever a concave mirror forms an image of the same size as that of the object, that means whenever I is equal to O, we have to take a negative sign here, because the image will be inverted, and once we have the image inverted, it is very important for us to write this negative sign. Now we know that from the question that I is equal to O. So I will write here, since I is equal to O from the question, I can write M is equal to minus 1 divided by 1, because I and O cancels, we get minus 1 by 1. So we can write the value of magnification as minus 1. So magnification, we got it as minus 1 here. Now since we have got the value of magnification to be minus 1, now we know another formula for magnification, that happens to be M is equal to minus V by U. Now I would substitute minus 1 here. So when I substitute minus 1 here, I get minus 1 is equal to minus V divided by U. U goes to the other side, gets multiplied, and we get minus U is equal to minus V. Minus and minus cancels, so we get U is equal to V. So finding this is really important, because in the question we have the height of the image is equal to the height of the object, or size of the image is equal to the size of the object, and now we found out that the distance of the object is equal to the distance of the image. Now what we would be doing here is we would be using the mirror formula that happens to be 1 by f is equal to 1 by v plus 1 by u. Now see, the question had asked at what distance from a concave mirror of focal length should an object be placed. So we need to find the object distance. So it is better we write v in terms of u. So what happens here is I get 1 by f is equal to 1 by v can be written as 1 by u plus 1 by u remains as 1 by u. We can write it here since v is equal to u. So after this I write 1 by f is equal to, we'll be taking the LCM since both the terms are u, the LCM will also be u. So I take the LCM, that happens to be u, and here what I get is 1 plus 1. So I get 1 by f is equal to 1 plus 1 is 2 divided by u. Now we need to see one thing here. The focal length is given as 25 centimeters. So we need to consider f is equal to 25 centimeter. But since it is a concave mirror, we will be considering it as minus 25 centimeter. So I would be substituting f is equal to minus 25 centimeter here, and what I get is 1 divided by minus 25 is equal to 2 divided by u. So u goes to the other side, so we get u is equal to, and this 25 comes here, 2 into minus 25. So we get the value of u as minus 50 centimeter. So we can write the object is placed 50 centimeter in front of the mirror. So we can write this actually here. So we have got the object distance to be 50 centimeter in front of the mirror. Now I would be discussing about an easier method of doing this problem, slightly easier, but might not be accepted by all the teachers. So here what is given is the same question I have written here: at what distance from a concave mirror of focal length. Now if we know the ray diagrams, we can write, we know that when the object is kept in front of a concave mirror at center of curvature, the image is also formed at center of curvature and is of the same size. So we can write, we know that object size and image size are equal when the object is at center of curvature for concave mirror. So if we write the statement, after that what we have to do is I have to find the value of, the distance of center of curvature. That means I need to find the distance of radius of curvature. So f is given as minus 25 centimeters. Since it is concave, we consider it to be minus 25. So r, that is radius of curvature, is going to be equal to 2 into f, that is going to be equal to 2 into minus 25, that happens to be minus 50 centimeter. As you can see, we have got the same answer, so we can write 50 centimeter in front of mirror. So hope you guys have liked the video. Do share it with your friends and consider subscribing to the channel. Question number 6 onwards will be done in the next video, the link for which will be provided in the description below. Dhanyavad.